Exercise data type and overview. This exercise corresponds to the video linked at the top of the page. The project folder has been uploaded to GitHub, and you can find the repository link in the video description. Additionally, the GitHub repository address is displayed at the bottom of the screen. To keep the video concise and focused, I have prepared the code in advance and will be explaining it step by step. The objective of this exercise is to explore different data types in C, particularly those that occupy the same amount of memory across various microcontrollers such as ARM, ESP32, and AVR. We will introduce syntax structures that remain consistent across different platforms, ensuring portability in embedded systems programming. To provide clarity, I have documented the code beforehand and included the necessary standard C libraries in the project. The implementation is structured within the main function where we define and analyze different data types. In C, data types such as char and integer can be defined using standardized fixed width integer types from the stdint.h library. In the Eclipse IDE, hovering over these types reveals their definitions. For instance, uint_h underscore t is defined using typedef as an unsigned char here. Here, the u in uint_h underscore t indicates that it is unsigned, and the t at the end signifies that it is defined using typedef. To locate its definition, simply right-click on the type and select Open Declarations. As you will see in the stdint.h header file, uint_h underscore t is redefined using typedef. All such definitions can be found under the exact width integer types section. Now, let's return to main code. To examine the memory usage minimum and maximum values of these data types, we define 8 variables. 4 of them are signed, allowing negative values. 4 are unsigned, storing only non-negative values. They are implemented using 8-bit, 16-bit, 32-bit, and 64-bit integer types. Using 8 printf statements, we determine both the memory size occupied by each variable in bytes and the maximum and minimum values that each data type can store. To retrieve the memory size, we use the Sizeof function, a fundamental feature of C that returns the size in bytes of a given variable or type. This function will be explored in greater detail in upcoming videos, where we will also dedicate an entire session to function in C. To obtain the maximum and minimum values for these data types, we use predefined macros. If you are unfamiliar with macros, I recommend watching our previous video linked at the top of this page. Additionally, you can explore all our videos in the playlist at the end of this session or by visiting our channel homepage. For example, consider uint_h_max, a macro representing the maximum value of an 8-bit unsigned integer. To locate its definition, right-click on uint_h_max and select Open Declaration. Alternatively, use the shortcut F3 key on the keyboard while the cursor is on the macro. This will take you to the limits of exact with integer types section, where all such macro are defined. When using printf, there are a few key considerations. Number one, handling Sizeof output. The Sizeof function returns a value of type long unsigned int. To properly display these values using printf, we must use format specifiers such as %LLU for unsigned long or %LLD for signed long. If incorrect format specifiers are used, the compiler will issue warnings. Number two, displaying multiple variables in printf function. Each variable requires a separate specifier. Use %u for unsigned integers. Use %d for signed integers. After compiling and running the code, the console output will display the memory sizes and value ranges for each data type. In our next video, we will discuss best practices for naming variables, macros, and functions, ensuring readability and maintainability in C programming. Thank you for watching, and I look forward to seeing you in the next session.